Okay, question 12. Right, so the limit, so continuous, to determine f of x is continuous or not at a certain point, we have to find the limit and that value. So find the limit first, limit x approach 0 of f of x. So we divide into two different parts. The first part is the limit x approach 0 from negative side. Then we have to use this one, okay? That becomes the limit sine 2x over x, and then minus 3. This one we have to multiply 2 over 2, and then move this 2 to here, alright? So this, okay, is sine, kind of like sine x over x when x approaches 0, that equals 1. You have to remember that I mentioned many times. So this is 1. 1 times 2 is 2. 2 minus 3 is negative 1. Okay? And then if the limit x approaches 0 from positive side, okay, then we use this. You'll be negative cosine x. Cosine 0 is 1. Times 1 become, times negative 1 become negative 1. So the left limit equal the right limit, so we can say the limit of this equal negative 1. And then f0 equals 0 minus 1 equal negative 1. Okay, so you have to write the key sentence is the limit when x approaches 0 of f of x equal f of 0. So yes, it is continuous at x equal 1. Okay, this sentence very important. Okay, and this LHL equal RHL. The limit exists. Also need to write it down. Okay, question 13. Okay, you have to draw h of x first. This okay, this wall equal x squared. That equals g, the limit x approach 0 of h of x. You can see when x approaches 0 either from left side or right side, the value of y is always positive. That means when the x approaches 0, the value of x approaches 0, the value of y will approach 0 from positive side, from above. You will never go negative. So that means that equals the limit x approach 0 from positive. Why here is y become x here? Because the output of h of x become the input of y. So you see this graph, the y will approach 0 from positive. That means x will approach 0 from positive for g of x. And then we have the g of x. X approach from positive, that equals 1. Right, from positive side. Okay, how about opposite? Okay, and then we have to divide two different parts. First is the limit x approach 0 from positive side or negative, whatever, of g of x. Okay, that equals 3. Approach 3. Okay, and then like this. So that's approach 3 from negative side. It doesn't matter, but I just want to let you know that's approach 3 from below, from like a 1, 2, 3. So from below, so from negative side. And the limit x approach 3 from negative side of h of x equal 9. The limit x approach 0 from positive side of g of x. That's 1. That's 1 from positive side. And the limit x approach 1 from positive side of h of x equal 1. Okay, RHL not LHL, not equal to HL, LHL. So the limit does not exist. Okay, this one is easier. X equal -1 of f of x. So -1 is here. F of x is 1, 2, 3. So 3 plus g of x, -1, that's 1 and 2. That's 2 equals 5. That's it. Alright, finally, next questions. Multiply the conjugate, right? So that's root 4 plus root x plus 3 divided by 4 plus root x plus 3 equals the limit x approach 25. Alright, that's a squared minus b squared. A squared is 4 plus root x minus b, that's b squared is 9. Alright? And don't expand this, just leave it in fraction form, x minus 25. And then 4 plus root x plus 3. Okay. This is what? This is root x minus 5. But this x minus 25, we can think as root x squared minus 5 squared. So we can, that's a squared minus b squared, right? So also can divide into root x plus 5. Oh, so this is minus 5, sorry. And then root x minus 5. And times alright, we can cancel out this and then directly plug in 25 for here and here. That would be what? That would be 1 over 5 plus 5, right? And you plug in root 25 here and root 25 here. That's perfect. Root 25 here, that's 5. 5 plus 4 is 9. Root 9 is 3. 3 plus 3. So 10 times 6, 1 over 60. Beautiful number. Done. Okay, we finished the quiz. Okay, let me know if you still have some questions.